Hello.
Oh, hey, how's it going?
Good. How are you?
Pretty okay. So I guess starting off, did you want to go with an introduction?
Sure. You want me to start?
Yeah, go ahead.
Okay, cool. So yeah, I'm a software engineer. I have about a year and a half of working experience um, as a full stack engineer. I have a master's in computer science, and I'm currently interviewing for new positions.
Cool. Sounds good. I guess similar software engineer. Not really interviewing at the time, just kind of doing these in my spare time. I used to use this a lot.
Hmm.
On the other end, like more than a year ago. It's cool.
Cool.
Uh, I just have a couple of, algorithm type questions I was gonna give out. We can go ahead and start with, I guess, a simpler one. Did you have a
Okay.
preference for languages?
Yeah, I'm gonna use Java.
Sure. I'm
Yeah.
gonna switch that over. Cool. And for any of these, if you've seen the question before, just let me know,
Uh-huh.
and I can, give another one.
Sure.
So this problem, I'll let you read it over, but the summary is pretty much that you're given, the root to a binary tree,
Okay.
and you want to determine uh, what the average value on each level of the binary tree is, with the level being, the horizontal
Uh-huh.
sections.
Oh, each. Okay. So each level. Okay. Um,
Yeah, so like the 3 and the 9 2, and yeah.
I see. So, given a root, and these are all going to be integer values, and you said it's not a binary search tree, it's just a binary tree.
Yeah, it's
Um,
just a binary tree.
okay. So the output should be the size of the depth of the tree. Is
Yep,
that right?
yep.
Okay. Um, okay. Let's see. Just trying to see if I can ask any more, like maybe clarifying questions. But I think it seems pretty straightforward. Um, so it seems like I want to do a breadth first search here. Um,
Okay,
so like the first step would be um, breadth first search, um, and then um, so I guess the first step would be to like create the queue and put the root node in it,
okay,
and then I guess go level by level. Um, at each level, I want to keep the so I want to get the count and then basically add up the values of the nodes.
okay,
And then once I'm done with each level, um, yeah, when I'm when I'm done with a level, calculate the average, and I'll have some kind of result list that I'll add it to.
right.
Um, so it seems like at each level, I want to kind of see how many nodes are in the queue, and that's kind of I know that that's what my level is, and then um, I'll basically decrement the count until I get to zero while I'm popping things off of the queue.
Okay,
And then I will, um, I guess, add the value to some kind of sum that I have, and then add its children to the queue. Um,
okay. So you said you're gonna have you're gonna decrement some count. So uh,
yeah.
are you just counting in the number of nodes as you go along, or I mean,
Um,
it seems like you would kind of get that number. Uh, you'd kind of have that number as it is, right?
yeah. So I guess initially I'll have three in the queue. The thing
Okay.
is, I want to know are um, how many nodes are in this level. So when I pop off at three, um, I know that the count would be one at this point, and then I want to basically do it while count is greater than zero. I'll pop something off, so then I'll get a three, and then count is zero, and then I know I'm done with this level, and then I'll add
Right.
its children to the queue, which would be 9 and 20, And then I know that my count at this point is 2. So when I'm adding things onto the queue, I don't lose track of where that level ends.
Right.
Yeah.
Okay, so just one thing because I wasn't sure.
Hmm.
In Java, can you add? I'm guessing you can have multiple sets of information uh, within an item in a queue, right? Like normally in say Python or C++, you can
Hmm.
have a struct.
Uh-huh.
Um,
Yeah, I mean
do
you
you
can
have
have
something
a
similar?
yeah, I mean you can have a list of objects, but they have to be of the same type. You can't mix it like you could
Right.
in Python.
Gotcha.
Um, so I mean, yeah, I guess maybe I guess what you're saying is instead of putting the in our queue just the value, we could have some kind of object that has like the value, um, I guess maybe like the depth and um, maybe it's just like the value and the depth, and then I
I
could
see. Okay, I thought that's
uh,
what you were getting at originally when you mentioned counts, but okay.
yeah, I don't know. I mean, I guess I could do it that way, but
Yeah, probably either is okay.
okay.
Right.
Yeah, I think just the first way I thought it was kind of more intuitive for me. Um, so
Cool. Yeah. I
um,
mean, if
yeah,
that makes sense to you, we can
okay,
go ahead and code that out.
okay, cool. Um, so I think so with this editor, I don't know if I need a like the create the class and the main function and all that.
Oh yeah, I think I
I think
ended
it
up
got
actually erasing
deleted.
that.
I wonder
Yeah,
if you
maybe
can
if we
maybe if
switch the language and then switch
yeah
back, right?
okay I'll yeah. Do you want me to do that? Oh, okay.
Sure. Let me.
Okay,
Okay, cool.
cool. Nice.
Paste in what you had again.
All right. All right. Let me just run it to make sure it works. Okay. So yeah, let me delete all this, and then we'll have a function that will return a list of integers, and I guess we call it get averages. And this is so I'm guessing we're gonna have a like an object of that's like a tree node, something like that.
Hmm.
So we'll have a tree node, and then it will have a like a value, and then left and right pointers, and then we can create a constructor as well. Okay, and
Okay.
then the yeah the parameter here will be a just the root. Okay. Um, so yeah, like I mentioned, we need to create our result list. And then we're gonna have our queue. So I can just have this as a linked list of tree nodes.
Okay.
Um, and then I guess we can check if the root node is null initially. Um,
Right. So you
yeah.
do get the constraint that it's non-empty binary tree.
Oh,
So you
I
can
do. Okay.
assume.
So I
Uh,
okay. So I guess I don't
yeah.
need to check for that. So I guess initially we'll just add the root to the queue, and
Okay.
then we'll do while the queue isn't empty. We want to dequeue for the first element. So I guess at first we want to keep we want to get the count, right? So count equals queue dot size, and then we know that this is the size of the level that we're on. So we can do something like while count is greater than 0, and then we want to make sure we decrement that. And then we also need our sum But I'm guessing when we when we get the average, we want to do sum divided by count. So maybe we don't want to mess with this count variable. Um, so maybe we want to just do like a for loop here.
Okay.
I is less than count. So like I mentioned, so we need to do a few things here. We need to add to the sum, and then we need to add children to queue.
Right.
Right. I think that's all we need to do in the for loop. So we'll do. So I guess, oh, and we also need to dequeue, right? So how do I want to do this? So maybe we'll have a tree node pointer here, and then we will do p equals q dot poll, and then we will do sum plus equals p dot val, and then we'll add the children. So we'll do I guess we'll check if it's null first. So if p, so if it doesn't equal null, then we want to add it. P dot left, and then we want to do it the same thing with the right side.
Okay.
Okay. And then finally, when we're out of this for loop, we want to add the average. So we'll do result.add sum divided by count. And then finally, when we're done with that, we want to return our result.
Sure. Cool.
And
So I
so
guess
yeah, I think we're done there. Is it okay if I test this out?
yeah, let's go ahead and do that.
Okay. So you want me to just create like a, kind of an example tree here? I'll just use your example.
Yeah, we can
Okay.
go through a couple examples, I guess.
Okay.
Really, I guess even the one, because there's no empty binary tree, that's not really an edge case, right?
Right. Right. Um, okay. So let's create the root. Right. Okay, and then we will, I think we could just system.out this.
Right.
Averages, roots. And then this needs to be a static method. And okay, so let me try and run that. And I think the class also needs to be static, since the whole class is static. Since yeah, let me try that. Variable sum might not have been. Oh yeah, I need to initialize this.
Cool.
So
Yeah, I think the only thing is
yeah.
the integer division.
Okay, yeah, right. So yeah, with round, it rounds down. So I think I need to make these doubles, or I need to make the count a double. Not the count, sorry, the sum. The sum is a double, and then when it does, yeah, sum divided by count, I think these, I might need to cast this to a double here. So the double cannot be converted to
Okay.
integer. Um, so, mm, oh, cause wait, oh, cause of the result list is integers, so these should be doubles. And then I think we want to still cast this to double here. And then the return result will be a list of doubles.
Right. Yeah, I think
Okay.
yeah, I think for the most part that this one test case is probably okay, just because the core logic seems fine, and yeah, there aren't that many edge cases you'd really have to consider for this.
Uh,
Sure. So did you want to go through another question?
um, yeah, I think that went pretty quickly. So yeah, if you have time, I'd love to do another
Sure.
question.
Yeah. So the second question, I don't really have the full pasting for it, but I can kind of write it down here. So basically, the idea of the second question is that you're given a 2D matrix,
Mm-hmm.
n times m size, and all across the matrix you have basically a series of unfilled cells, which are just zeros. You have unfilled cells, which
Okay.
are zeros. You have some walls, which are labeled with the value -1, and then you have some starting points, right? Um, you can call them,
Okay.
gates or something, which let's say they're labeled with -2, right?
Yeah.
So you want to update the entire matrix so that the entire thing is filled, such that all of the cells which originally had a value of 0, they now instead indicate the closest distance to a gate. And the one condition when you're calculating distances is that you actually can't pass through walls. So
Mm-hmm.
let's say you had a super simple matrix, which is just kind of 0, 0, 0, -2, put a -1 here, 0, 0, 0, something like that, right? In
Okay.
order to get the distance to, let's say, this one to the negative, to the left of the -1, you'd have to go down from the -2, then left, left, and up. So you'd have 1, 2, 3, 4 is the distance, and then 3, 2, 1, right? Um,
So right here, our starting point would be that where the four is, or
our starting point is, so you're trying to calculate the closest distance from the -2.
uh-huh.
Uh, the starting point can, kind of be, it's, I mean, that's kind of a part of the problem you're trying to figure out. But the basic thing is that when you do calculate distances, you can't go over these cells that have a -1 on them.
Okay. And then what is the output?
It's this modified matrix, which indicates the distance
Oh.
from all of the unfilled cells to the closest gate.
Oh, okay.
So there could be a second gate, right? Let's say this is
Uh-huh.
-2, then this would get updated to 1, 1, 2, and then the rest remain the same.
I see. So the shortest path to any gate without hitting a wall. It's
Yeah,
it's
pretty
kind
much.
of okay.
That's what the aim is.
Okay. Hmm. So it seems to me like we should have like our starting. So say we have one gate. It seems like we could just do. Um, we could start at the gate and then do like a breadth, do some kind of search, like a depth first search, while we're
Okay.
incrementing one to like at every neighbor that we get to. And then so say we have say we just have this -2 here, and then say these were all zeros except for the wall with the -1. Um,
Yep.
yeah, what we could do is we could do like let's just say like a depth first search. So where we go down and then we add one, and then we try to go to the right, up, and left, but we see that we can't because we're either out of bounds or we hit a wall. But then we recurse
Okay.
on this one here but now our value is 2. So then we see we can't go right or down. We already went up, but we see that we can go um, to the left. So then we would add 2, and then we would keep doing that. But then this would be 3, this would be 4, this would be 4, and this would be 5.
Okay.
So it seems like that could work. Um,
Yeah. That definitely
we would
seems like
also need to keep track of which ones we've already visited. So I
okay.
guess that we could maybe just check if it's not equal to 0. That means we've already been there.
Right.
Um,
Sure. Yeah, that seems like something that would work out when you have one,
right.
gate. But what if you had, say, multiple? Right.
If we had multiple, um, I guess the first thing that I can think of is we first do this search on -2, and then we have this result, and then maybe we look at the next gate and we do the same thing, and then we would update our value um, if it's less than the one that's already there.
Right.
So this would say this
Um,
one was -2. So we did our first search on the top right -2, and then we go to this other -2, and we start here. Then we go 1. We
okay.
see 1 is less than 5, so we update that. We see 3 is less than, or 1 is less than 3. Then we go up to here. We see that 2 is less than 4. Then we go to the right here, and we see that 2 is equal to 2. So I guess we would just be done there.
Right.
And then if we ever hit a -1, I mean, an out of bounds and a -1 would lead to just terminating um, that path. Um, but then I guess, I mean, the only thing here is we're doing multiple breadth first searches for each gate. I don't know if there's a way to optimize that, but and then the other thing that we need to worry about is, remember I was saying if we've already hit a path, then we would check if it's 0. But then on this second case, none of them would be 0. So we
Right.
need to kind of keep track of where we've been. Um, so so maybe we could do some kind of backtracking where we would set it to 0 and then like keep going along our path. And then once we're done, then we'll just set it back to whatever it was before.
Okay. Yeah, I'm pretty sure you'd have a bunch of different options on how you'd want to do this.
Yeah. I
Like I
mean, we could
think
also keep
just
like,
doing the less than comparison works out, or a visited set like you suggested. Um, yeah, I think either way is okay.
yeah. I mean, or we could just have like another matrix that keeps track of where we visited, but then that adds additional space. Um,
Right.
but yeah,
Yeah, I think like either thing is kind of okay. Like it's
hmm,
it depends on how you kind of structure the rest of your code.
yeah,
I want to say.
okay,
So yeah, I'd say overall this sounds kind of okay to me. And the smaller details, we could resolve as we go along.
uh-huh.
What is the complexity for this end up being
So the way that I was
for your
gonna do it
approach?
is loop through the entire matrix and then look at all the -2's. So that
Okay.
itself would be m times n. And then for each one of these, we're doing a breadth first search or a depth first search, either way. Say we're doing a depth first search, that would also be n times m.
Okay. And you're
Uh,
doing it once from each gate, right?
yeah, so once from each gate. So say these were all -2's, then I would have to try and do a breadth first search on all of them. Um, so it seems like that potentially I could have m times n times m times n times m. So I think it would be m squared times n squared.
Yeah, I think that's how it
Yeah.
ends up working out. If you multiply the number of gates with the size of the matrix. Sure.
Okay.
And I guess for space complexity, you mentioned you're not creating
So
another matrix, right?
yeah, I think initially I'll try not to do it with another matrix. And then if we are doing a depth first search, we have to, um, we will have a like a call stack that we need to keep track of if we're doing it recursively. And that could potentially be n times n.
Right.
Yeah.
Cool. Yeah, it sounds good to me, and we can
Okay.
probably code this out.
Okay. So is the input? It's just going to be an array, right? A 2D array. Um,
Yeah.
so I guess we'll call it. Let's call it matrix input. So I'm thinking here, since I've decided that yeah, I want to do it recursive or a depth first search. So I think we should have a helper function here that does that.
Okay. So one question during
Yeah,
the when we were talking about it, you mentioned both BFS and DFS.
yeah.
So what makes you choose one over the other?
Um, I guess it would be. It's usually cleaner to write it with as a depth first search. It's just like
This is the recursive portion.
yeah, just the
Gotcha.
recursive
Okay.
part is kind of a more elegant solution.
Got it.
Yeah. Okay, so in our depth first search, we're gonna have the matrix, and then we're gonna have our row and our column, and then we also need to have our, I guess, our depth.
Okay.
So initially, we're gonna call depth first search on matrix 0, or actually, we're gonna do a search first, right, to see where the negative 2's are. Plus. Sorry, these need to be row.
And again, I guess you can assume that you're not going to get like an empty matrix.
Okay, so yeah, it'll have at least one row. Okay.
Yep.
So we'll do if input row, column, and 0. And then let's just change this to input for consistency. Okay, so yeah, so we go through, and then every time we see a negative 2, then we want to do a search here. So I guess maybe we should first check our boundaries here. We either check, maybe we'll have a function called isSafe.
Okay.
So we'll check if it's not safe here, and then that will take in the input, row, and the column. So this will be whether we're out of bounds or we're at a negative 1, or if we're at something that we've already seen. We'll just do a return, and then I can code this up later. Okay. Let's do true for now. Okay. Okay. So at this point, we need to. So initially, we're calling it. So I'm trying to think of here on line 44 if we should initially call it on all the neighbors, or or we should do that
on the cell
here.
itself.
Yeah, cause at this point, I don't really want to check it on the negative two. I want to check it on the neighbors. Um,
Right.
so maybe we should do that initially here. Okay, so that should get all the neighbors. So now, and then we should pass this in at 1 since we've gone, I guess, path of 1 or depth of 1. Um, so I guess at this point we will check. So we know we're not out of bounds. We know we're not at a -1. So at this point we'll check if we've either already hit this or if it's less than. Um, well, I guess the is safe already counts for if it's already visited that one, that index. So I guess at this point we'll say
Right.
if input row call is if it's greater than our depth, then we want to set it to our depth. And then at this
Okay.
point we want to recurse on everything. So we'll just copy that. So I think the general algorithm that I mentioned is this would work for it. Let me see here. So yeah, so we go through everything. We see we have a -2. We go to all the neighbors. So in this case, just going back to the example, these would all be zeros. So we'd go down, and then we'd see that. So I guess this case would fail here. If it's a 0, then input row call would never be greater than depth.
Right.
So maybe we should check if it's also 0. So if it's 0, we set it to depth.
Right.
Otherwise, or if it's greater than, then we would also set the depth.
Yeah, I guess that makes sense to me. The
Yeah,
main thing is on your is safe method.
yeah. So let's do that right now. So we'll do um, if row is less than 0. Length. So that checks if it's out of bounds. We also want to check um, if it's a negative or if it's a wall.
Right.
And then I think we have one more case, but so if that's true, we want to return false. We also need to check if we've already visited it. So
Okay.
I don't know if we should do that in here or
It seems like
yeah.
what is it? When instead of short circuiting, your code is set up so that you'll just end up picking the min over multiple DFSs, right? Like, isn't that the condition for roll call being greater than depth? Isn't that kind of what it covers?
If row for which part?
On line
Oh,
60 for the second condition, and if it seemed like you were just gonna, instead of short circuiting, just run DFS multiple times. In which case, you're not keeping track of a visited, right? You're just going ahead and doing that check anyways.
Um, sorry, I wasn't really sure what you meant. Um,
So on line 60, when you have the comparison, to row call is greater than depth, the
yeah.
only way that you can end up hitting that condition is if you're just going to go through and uh, revisit each cell, right? That was initially a zero, but maybe now it's not a zero.
Um, I think
If you
well,
had visited, it seems like it was to short circuit.
I think this input is greater than depth was meant for when we do another breadth first search and the value's already in there,
Yep.
right?
Yeah. Yeah. Yeah.
Um,
Oh, is the visited referring to something else? Oh, it's on the same DFS. Okay, gotcha. Got it.
yeah, yeah. So right now I'm kind of thinking of maybe if it would have been better to just keep like a separate matrix for visited. I think it would have made things easier. Um, do you want to try and run this and see what it looks like? Or
Yeah, but now that I got what you meant by the visited, well, you could see how that would kind of loop infinitely.
so if if input row, so I think the input row column. So if it's, let's see, if it's greater, hmm,
So on a single run of DFS, you would need a separate matrix or some visited set.
yeah,
I'm would be my guess based on how
mm-hmm,
this code is structured.
yeah. So I think it would be maybe we'll have a matrix for visited because I was kind of trying to
Sure.
use the input matrix, but yeah, I think it would just be make things simpler if we use a visited matrix. Um, so so yeah, let's do that here. Okay. So initially, I think we should set the root or the one that we're currently on to visited equals true.
Okay.
Or I guess equals, we'll just have a 1, I guess, for visited. Um, and then we need to set it back here. I guess, yeah. And then we can do the same thing here. And then in our safe method, we can check if that visited has already been set to 1.
Sure.
Okay, so I guess I think we could even remove this input call equals 0 because we don't need to keep track of the visited in our input set. So I think we can get rid of that. And then we just check if input row call is greater than depth, then we set it to that depth. Um,
Sure.
Yeah. So, and then we set visited equals 1, which is the current uh, index that we're on, and then we do depth first search. Um,
Okay.
okay.
Uh,
Is
I'm
it?
guessing
Yeah.
that's the portion. That kind of sounds good to me.
Okay. You want to try
Let's
and
go
run
ahead
it?
and try and test it out.
Okay.
Yeah.
So I'm gonna go ahead and delete this here. Um, and public static. So I didn't give a name to this method. Um, public static. Oh, I did. Yeah, it's called matrix. Okay. Um, input. I guess. I'm just gonna copy this for loop here.
Oh, I guess can you not just you can't just print out
No, it
like a
would just.
multi-dimensional array.
I think it would just print out the index or the address in
I
Java.
see. Gotcha.
Yeah. You can do it with collections, but I don't think with primitive arrays you can do that. Okay.
Gotcha.
So yeah, let's go ahead and run that. See, I'm probably missing. Let's see. Error. Oh, I need commas between these. False. Mm. Error method DFS cannot be applied to given types. I think I forgot to.
Yeah,
Yeah, I
visit
think it needs
exception inside
it
the
needs.
function prototype.
I see. Oh, visit it, and then I need to add it to the recursive call.
Okay.
Missing return statement. Oh, I need to. I guess I don't need to return it, right? I could just have a void. Since I'm just manipulating the data that's passed in.
Right.
Okay, so it ran,
It
but it didn't
seems like looking at it,
do anything.
yeah, it didn't modify anything.
Yeah. It didn't modify it. Did I not ever set it? I don't think so. I think because it's originally 0, so it won't ever. So I think I do need to keep that case where it's if it's 0, I need to set it, right? So like this line 67, if input row, since it's so this would never be true, right? Because initially they're all zeros.
Yeah.
So if I do if input row call equals 0 or that. Let's see. Okay, so I never incremented it. So this should be depth plus 1.
Right.
Okay.
Yeah, that seems to be kind of the thing we'd be looking for. Uh, yeah,
Cool.
I guess the main other test case you'd want to check is if what if there's a bunch of gates or what if they're all guards. But I think the core
Hmm.
logic is totally
Okay.
fine. So this isn't something we'll have to code out as just more of a discussion. So uh, the way this is kind of set up is you're running DFS from all of the gates, right? So let's say that there's G gates. So then the complexity is kind of a G times N times M, right? Um, do you think there's a way that you can actually speed this up in a sense? So, totally valid for using DFS in the sense that it's definitely a lot simpler to code.
Hmm.
If you were to try and optimize this, um, do you see any way that BFS might be helpful for that? It's not really required, but it's just kind of like a small, you
Um,
know, small thing.
so if I ran BFS instead of DFS, how would it change the time complexity? Or,
Yeah. So let's say you didn't run, you know, uh, let's say you didn't just queue up one item, right,
uh,
and then run DFS there.
so if I didn't queue up, so if you're saying if I didn't run DFS for every item,
Yeah.
how would it improve if I use BFS?
Is there a way you could use BFS?
Um,
To kind of think about it, we are so a large portion of the waste ends up being when we have overlap, right? You kind of already know that as soon as you meet a smaller number, you can terminate your search at that point, right?
right.
Down that path.
Hmm.
Um, if you're using BFS, it might be really simple to kind of, you know, uh, see that terminating condition.
Hmm. So, okay, so you're saying, yeah, in depth first search, I terminate when I see
So the
that,
DFS or with the existing code, you could probably do this with DFS as well.
yeah.
It's you have a large section of your search which overlaps with previous searches, but you can definitely search in a way such that you don't visit the same cell twice.
Oh, could you run like concurrent BFSs? Is that,
Well, you mean concurrent as in multi-process? Because
um,
you don't have to do that kind of thing, but
maybe not
uh,
multi-process,
I,
but
I
maybe
think
like taking turns? Um,
yeah, that does sound like in the right direction. So
yeah.
how would that be structured?
So maybe you would have to have different queues for each breadth first search that you're doing. And then you can go like layer by layer. You can like take turns on each one, doing like a round robin, and then you go like one depth for each turn. And then that way, if you ever hit a node, or I guess, or a like a row column that's already has a value in it that's not 0, then you know that it's already
Yeah,
been visited by something else, and you know that that's already guaranteed to be the shortest path from whatever the previous, like wherever the previous route was, or the route for that particular search.
right. Yeah, I think that does hold. So you mentioned round robin.
Hmm.
Is that any different from kind of using one queue? Like what changes between those if you were to put all of the items on a single queue versus all of the items onto multiple queues.
Um, yeah, I'm trying to think of maybe if it would make a difference. So yeah, I think you actually probably would be able to use one queue, and
Okay.
you would first go through like 0, 0, -1, -2, and then maybe you like add all of its neighbors, um, or all add all the valid neighbors, and then you could keep going through. Once you get to the second -2, then you add all its valid neighbors, um, and then at that point you don't really care what the starting point is, or like you don't care what your root was. Then you pop off the queue, and then you look at all its neighbors.
Right.
Right. So you would have to keep track of, yeah, just the row and the column that you're currently at, and you can keep that like maybe like in an object in your queue. Yeah. So I think
Cool.
yeah. So
Yeah.
I think you could do one queue for that. Hmm. And then yeah,
Yeah.
you don't have
It's
to.
and yeah.
You're not going over the same node. You're never like going over the same node again, or the same index.
Yeah. It just kind of ends up working out so that yeah, you'll pretty much end up ending at the exact point that you have overlap with something else. So
Right.
it, the improvement on this just ends up being that you get rid of the G, so
Uh-huh.
there's just n times n complexity. But, doing something like that is not really required. Yeah, cool.
Okay.
So I think that's pretty much time, and I'd say it went pretty well. The
Uh-huh.
interview with solid clean code and tests,
Cool.
as well as communicating and all that. Did you have any questions for me?
Um, no, I really like the questions. There were kind of questions that, I mean, I've seen like variants of like breadth first search and doing like these type of search problems in Excel, but I've never done a problem like this. Um, yeah, I mean, I did like how you did help me out when I was struggling a bit. You didn't like immediately give away the problem, but your hints were very helpful. Um, and yeah, other than that, I guess yeah, that's I guess I'll have more feedback as well when I write it up. Um,
Cool. Okay.